of the day for this Atal FDP. Speaker, a research assistant professor at AI Khobar, Eastern Saudi Arabia. I'd like to summarize his education first of all. National Institute of Tech. After that, he was an associate professor at Charuset University of Science and Technology for 17 years and 8 months. He has a very vast experience and he is also connected with Prince Mohammed bin Fahad University as a research assistant professor till February 2020. So he was there for 5 years. His areas of interest is machine learning, digital image processing, FPGA-based signal processing, embedded system design. He has top skills in programming in artificial intelligence and deep learning. His tremendous information, caring for the publication. Few examples I can narrate over here for his publication is like a low cost and efficient cloud monitoring camera system design for imaging satellite TM11 to HE11 mode converter in overmoded circular corrugated waveguide, obscure image classification and restoration using support vector machine. Another one is automatic room information retrieval and classification from floor plan using linear regression model. More is a robust autonomous navigation and mapping system based on GPS and LiDAR data for unconstrained environment. Apart from that, he has a great achievement that he has got 2 patents, recycling and disposal unit waste management system. I heartily welcome you, Dr. Hiren Mewada, sir, to please convey your information and share your knowledge to all the participants all over India. And I'm glad that you are here on this online platform. Welcome, sir. And now the stage is yours. Please hold the online platform. I'm stopping the share screen so that you can share your screen, sir. Thank you, sir.
Thank you very much. I hope my presentation is visible to all of you.
Yes, sir.
Just changing also. Yeah. Okay, thank you very much, Dr. Vanna, for that kind introductions. And I am happy to be here today to speak with all of you. As I mentioned, my today's topic is implication for the diagnosis of artificial intelligence-based histopathological image classifications. As a part of this talk, I'm going to cover the main 8 topics. I'm just in a start. I will start with AI and the machine learning in the diagnosis. Then I will talk about the various cancer types, and then how the histopathological images has been captured and they are examined for the classification of the cancer. I'm going to talk about for that. Later on, I will talk about the various data set. Just quickly, I will introduce the large number of the data set which is available. And then I will focus on the classification of the cancers using the deep learning and the CNN methods. And finally, I will conclude the talk with challenges. And in the challenges, specifically, I am concentrating on the 2 parts, the clinical challenges and the neural network-based challenges. So we know that AI, the artificial intelligence, and the machine learning are gradually strengthening their impact on the everyday life. And we are believed to have the dominant influence in the digital healthcare for the disease diagnosis and the treatment in the near future. And the machine learning is the subset of the AI, where the neural network-based algorithms are developed to allow the machine to learn and to resolve the problem like the human brain. In turn, if we say that deep learning is the subset of the machine learning, which mimics the human brain ability to process the data to identify the image or the objects, It processes the languages, it improves the drug discovery, and it can upgrade the precision medicines. It can improve the diagnosis, and it can assist the humans in making the decisions. So altogether, AI and machines are largely utilized for the decision-making process. And if I look at the images, if you see in the images that how the AI, machine learning, or the deep learning are used in the digital healthcare and in the biomedical image processing with signal processing to solve the healthcare issues and to predict the optimal treatment, where you can see it start from the oncology, where drug discoveries are there, then it goes for the digital pathology image classifications. And then we have the next generation sequencing model is there. And lastly, we have the data management is also utilized using the large language model based deep learning algorithms. So if I see here, the AI is the commonly defined as a set of computer coded program, as we know. And it is just like algorithm which use the data analysis and the pre-program instructions to make the predictions and the decision about the various aspect of the disease. And the machine learning is the specialized field with the AI, which refer to the group of algorithm designed to learn and improve from the experience automatically. In other words, if I say the machine learning is AI subset that focus on the developing algorithm capable of learning from the data and refining their performance over the time. And the deep learning, lastly, is a subfield of the machine learning which employs the neural network based model to intimate the human brain capacity to analyze the large or the huge amount of the complicated data in the area of such as large language processing, drug discovery, and the image and the signal recognitions. So altogether, if I want to differentiate or if I want to compare these three models, the two models, machine learning and the deep learning, so we can see in the diagram B, the comparisons are shown. And in the deep learning, combines the pre-processing, future extractions, future selections all together to classify the images. So we can say that the deep learning is more advanced stage or the automated an approach over the machine learning. In the machine learning, we have to extract the features by the human and then we have to train them for the identifications. So let me illustrate that what are the potential areas in which the artificial intelligence can be integrated into the diagnostic workflow for the patient's cancer identifications. So altogether, the overall uh, AI application has been categorized into the 5 stages. It starts from the screening, then it goes to the diagnosis, then we have the staging, then we can go for the treatment identifications once the cancer is identified. And lastly, we have to follow up or we have to take the response from the patients so that how the effective it would be, the treatment would be there and how accurate it would be. So when we talk about the screening is used for the early diagnosis purpose. Like we know that mammography is the most common screening test for the cancer. And however, the standard screening using the two-dimension mammography is not without caveats. There is an inherent difficulty in detecting the cancers using the two-dimension mammography because of overlapping of the structure in the pathological regions. If you look in the tissue structures, the high density, like high proportion of the glandular and the fibrous tissues can make the potential tumor and make them appear similar to the normal tissues on the mammograms. And therefore, the attention should be directed. It is required towards the development of evaluation of alternative technique for such a cases. So these are the challenges in context of screening point of view. And we know that a confirmatory diagnosis of the cancer can only be established through the histopathological examinations of the specimens or the tissues which are commonly obtained via needle biopsy. So now I am concentrating on the why histopathological images now. So if you look in terms of market, because the financial aspect is the another part, apart from the technological and the advanced development. If you look at the financial growth, though we can see that the AI in the cancer diagnosis market is grown very rapidly. And it has been expected that it will reach to the $1,943 million by the 2023, which is up from the US dollar of 175 million from the 2 days or of the year of 23. which represent that if we look in terms of annual growth rate, then it is around 26, 27% from the 2024 to the 2033. So within a 10 years, the growth will be the 27%. And the market segment, if we look based on the component, which includes the software solutions, the hardware solutions, and the services. So here, if you see in the graph that how it shows that how the growth in the market will be there from 2022 or 2033. So overall, there are three parts out there, as I mentioned. One is the software solutions, second is the hardware service. And if we look in the 23, the software solution segment lead to the market with 46%. And it has been projected that it will grow as the fastest during the forecast period with notable growing rate. So here, if I look here, the diagnosis in another way in terms of spider chart or the bar chart. So we can say that the market segment based on the three income paths, based on the type of the cancer that how the market goes now. So if you look at here that it includes the breast cancer, it includes the lung cancers, prostate cancers, colorectal cancers, and the brain tumors and the other types. And mostly the AI tools which predict the cancer likelihood is around the 86 to the 94% accuracy in the laboratory point of view or the clinical point of view in the practical purpose. And the AI-driven diagnosis solutions will play the crucial roles in early detections, in the treatment planning, and the patient management in the various clinical settings. The primary restraints hindering AI in the cancer diagnosis market encompass the data quality. What are the challenges are there? Like data quality, interoperability, and the regular compliance of the challenges. These are the few major challenges are there. In addition to that, we have the limited access to the high quality annotated data set, which poses the significant barrier to the development and the validation of the robust AI for the cancer detection and the classifications. So it is not in terms of like technological advancement, in terms of financial growth only. Financial growth also, it has the huge demand nowadays in the market. So let me start with a quick overview of the non-pathological fox, that how the biopsies are taken and how the tissues are prepared, and then how it can be used for the early diagnosis or final treatment for the beginning and the malicious classifications, and then finally to detect the cancers. So I'm just go very quickly with non-pathological fox and then what pathology is. So apart from the other things like genomic testing and the others, the mainstay of the pathology is the attendee stay in the tissue images. You can see the one tissue image which has been shown into the slides. So this tissue is taken out of the organs. It is put on the glass slide, and then we stain it, or we can use using some chemicals such that it will emphasize the characteristics of the stains or the tissues. And for that, we utilize some contrasting agents which give the contrast in the way that we can see its structure in the form of morphology and other things. Then the diseases are diagnosed based on the observation which is carried out. And so the pathologist always look at the color stain slides under the microscope. Sometimes they also do the other type of staining. For example, if I go like specifically the ISC steps, which can highlight the different features of the nuclei, and then the diagnosis it based on what they see under the microscope. So we know that the today's microscopes comes with a mounted camera, and later we can see the slides. But the things got realized with the availability of the other whole slide images. So very large slide images are available nowadays. An example of the breast, if I talk about the H&E stain images, whole slide images, which is captured from the BRC detailized. So we can see here, the graph is there, which illustrate that three title of the images, like the various zooming levels are there, the 10 time zoomings, 20 time zoomings, or the 40 times zooming for the magnifications in the whole slide images. And then this whole slide images has the multi-resolution pyramid also in the second part, the part B, at the level 0, level 1, or the level 2. And this everything we can do by using the certain signal processing applications. And sometimes we have the scanners. We scan the entire slug and give us the digital tissue images, which we can share using the computer network, and we can view over the digital monitors to do the diagnosis. And sometimes instead of zooming over using the microscope, we can use the digital zoom on the computer to look at the tissue structures and to do the tensor grading and other stuffs. So here the few samples of the stain images are shown here, where you can see that the first image in the diagram is the H&E stain images, and the second other approach of the staining is the ISC staining images, where the nuclei and the cytoplasm appear in the purple and the pinkish color respectively, and that color is established due to the contrast agents that is known as a hematoxylin and the eosin staining. Overall, these tissue structures can be classified in the three types. One is the, if I classify in the two types, one is the normal tissue and the malignant tissues. Again, in the normal tissues, we have the two types, in situ carcinoma and the invasive carcinoma. The problem with the images is that they are very large in terms of gigapixel, like 100 by 100,000 pixels. And therefore, the standard technique has the scaling problem when we apply the algorithms. In addition, there is a lot of variation with the tissues due to the specific type of the cancer. So we need the development of the algorithm which require that consider the fluidity problem while developing such a computational algorithms. Okay, so let me talk about that how the pathologist will see the structures and how they classify them. If I talk about the normal images, in the normal tissue, the architectures are well maintained, and if you look at the nucleus, they are well organized. If you see in the left side the images, the first one is the normal tissue images. Now, when the region in the organ or the tissue has suffered any damage, either through the injury or through the disease, just like an example of the wound or the ulcers or the tumor, then the structure is getting changed. And then they are known as a malignant type images. As I mentioned, there are two types are there, in situ or the invasive classifications are there. So in the in situ carcinoma, the second image, the cells are restrained inside the memory ductal lobular systems. If you look at the diagram, the black line which shows the region, the black border circular parts are there, and all the cells are restrained inside that black color regions. That is known as an in situ carcinoma. And in the invasive carcinoma, we can see that the distortion of the architecture as well as the higher nuclear density and the variability, where you can see that the tissues are going beyond the black boundary of the colors. So in the invasive carcinoma, the cells are spreaded beyond these structures, and these structures the pathologist identifies, and based on that they will classify that what type of the cancers we have, either in situ or the invasive, or it is a normal or it is a malignant type. So let me start with the data set. After the few slides, I will show that how many data sets are available online over the many literature surveys. So data sets in the classification plays the major role, because we know that the AI performance, the artificial intelligence performance highly depends on the availability of the sufficient high quality data. And using the large and the diverse training data set will allow us, or will allow the algorithms to identify the complex pattern and the nonlinear relationship more accurately. And if they are able to identify or they are able to distinguish these patterns, the cell structures, then they are able to classify the images well. Like other medical data, if I concentrate on the histopathological images only, then they are well protected by the ethical and the legal regulations related to the privacy, security, and the consent. So when we develop the data set and when we publish, we have to follow the certain guidelines of the regulatory. And when we want to share the medical data, the data owner must adhere to relevant regulatory requirement. If I talk about the suppose US regulatory, then one is the General Data Protection Regulations (GDPR) in the European Union, and the Health Insurance Portability and the Accountability Act, that is HIPAA in the US. And after the European Union, the GDPR revised the new regulation in that May 2018. The medical data sharing has become more challenging due to the concern over the maintaining the confidentiality of the patient's health informations. So now they are looking about the patient information should not be shared among the users, especially in the light of high-profile data breaches and the incidents of the data misuse. In addition to the privacy and security concerns, the IP rights or the regulatory issues can pose a significant barrier to the sharing the medical data. The research content can also limit the ability of the researchers to share the medical data, and the cost associated with the collecting, storing, and curating the medical data can be a substantial, and many research may lack the necessary resources for or the expertise to manage and share the data effectively. In India, we have the Digital Personal Data Protection Act, which is just developed in the 2023 year to share the data. So they have just mostly the norms are similar to the GDPR, the European Union's form, with slight change into the data sharing. So overall objective is that we have to identify and assess the characteristics of the all publicly data set available for the breast and the and H&E waste whole slide images. So here what I did that I have just summarized the few data sets, and then I will show the comparisons. So here you can see that it starts from the Acrobat, and we define the data set in terms of what image size are available, how many number of images are available, and specifically what applications they are targeting, like image registrations, image classifications, or for the grading purpose, or sometimes they are utilizing for the segmentation purpose. Segmentations means like tumor identifications or the local region of interest identifications will be there. Classification means we want to classify whether the tissues are malignant or the normal. Again, within a malignant, there are number of classifications are there, which we'll see later on. So that is known as a classifications. And the registration means if you have the small size of the images, so we can combine them to make the larger size of images to create the whole slide images, and then it can be used for the data management and the classifications. Then the further classification is based on the what type of images are available. When I say the whole slide images, that means the very large size, like 100,000 by 100,000 images are available. And sometimes these whole slide images are divided into the number of patches. Patches means I can say that you can have the few block or the size of the images which is obtained from the whole slide images, and they are storing over in the data sets. So if I take the example of ADP, that is one of the data set which is announced in the 2019 years, which contains the patches of 1088 by 1088 pixels, and the zooming level is provided by the 40x. And similarly, we have the large number of the data sets, which starts from the NHIR, BACH, BCNB, and the BRSCS. Then further data sets are like Breakis data set, which is largely utilized, and it is the only database which provides the 4 times zoomings, like 40 times zooming, 100 times zoomings, 200 times zoomings, and the 400 times zoomings. If you look at the other data set, they have the single zooming, maybe 40 or the 20 maximum, and they are providing the either whole slide images or the patches. So these are the list of the data set which is available, and the link of each data set is provided at the end of these slides in the reference sections. So if I compare the data set during the last 5 years only, and if I prepare the chart shows that how many papers has used this public data set for the cancer identifications, either using the H&E stains or the whole slide images or the patches, using the different artificial intelligence-based algorithm development. And the applications are mixed, like they are utilized for the segmentation purpose, they can be utilized for the classifications, or they may be used for the prognostic prediction or for the color normalizations of the histology images. So if you look here, the BRC image has been largely utilized by the actively used by the most of the researchers. And during this analysis, make sure that we excluded the review papers, because review paper also includes the data sets. So what we did, we excluded the data set from the list, while and we focus on the research paper only, those who are purporting the for the particular applications only. And if we see in the diagram B that how many applications have been targeted into the based on the type of applications, starting from the predictions, classifications, normalizations, detections or the segmentations, and for the other tasks. If you see here that almost half of the studies, like 52%, have been used for the BRCA, which is actively, which highlights the significance of this data set in the computational pathology point of view and its value as a research for the future studies. For multi-class classifications, as I mentioned, only one the data set, that is a break-hist data set, is available, which is the single data set which provides the 40 times 100, 200, and the 400 times zoomings along with the image patches. If I look at the challenges in context of the data sets, so one of the major challenge is the inconsistencies in the data sets, inconsistency in the data format, the structure, which are found across the various data set, and that could limit the interoperability of the data set. And these inconsistencies may arise because of the laboratory or the clinical staining process, because one laboratory follows the other staining process, the another laboratory will follow the another staining process, and because of that, the each data set has a different inconsistencies. Here, if we take the few examples, like what are the problems or the data set will be there during the staining process. So few images or the 8 images are shown into these slides, where you can see that the various type of artifacts may be present, and the quality issues in the histopathological whole slide images. If I look at the first image, like diagram or the image A, then it is the whole slide images from the BRCA with inconsistent staining. The staining is not proper. If I look at the diagram B, then the tissues folding in the whole slide image from the BRCA images. If I look at the diagram C, where the pathologist marker sign on the whole slide image is not appropriate. So this may cause that the region of the interest is not appropriate. If I go at the diagram D, that is a slide from the again BRCA, which shows the predominantly vacant areas. So it is not being captured well. If I look at the diagram E, then it is a blur images with a marker sign on the private data set. So actually the marker has been gone into the actual region of the interest, and therefore it caused the challenges in the identifications. And if you go at the suppose F images, the bubbles, there is a presence of the bubble in the whole slide images, which leads to the focal image disruptions. And if you go at the diagram G, this shows that there is a marker sign, the air bubble, and the inconsistent colors. Like in the right hand side, the pinkish colors are there, and in the left hand side, the pinkish colors are there, along with the blue color mountains are there because of the staining process. And in the left hand side, the colors are varying. So this is the inconsistencies may create the problem because AI is learning automatically from the structures. And lastly, we have the H, that is the whole slide images from the Warwick dataset, which shows that the marker signs on the slides. When there is a marker slide on the signs, that means we are masking the images, and because of the masking of the images, the model will not be able to classify them well. So among the, like, if I reviewed the 149 non-review papers, the pure technical papers, out of the 149, we observed that only 41 has incorporated the multiple data sets. That means they applied their algorithm on the multiple data set. And out of the 41, the 21 integrated the private data sets alongside the public one. That means they use their own data set also along with which is the publicly available for the model development and the validations. Notably, only 21 studies used external validation and the test sets. When I say the external validation, it means that apart from the data sets, they use the data set which is not used for the training purpose, and they try to validate their model. And this is the true approach for validating any AI model. And they implied that the performance of the other developed model could be subject to the overestimations. And therefore, if I look in terms of data set, it is very crucial to improve to the FAIR principle. FAIR principle means we have to apply the same model to the multiple data set, and we have to look that it will not address to any biases. So this is what about the data sets. So let me go now that how I am concentrating on the classifications as I'm narrowing my topics into the applications based on the classifications only. I'm not discussing about the segmentations or the registrations or any other applications. So let me start that what are the essential steps are there which is used in the AI to classify the images, whether it is a normal or the malignant type tissues are there. So what we have, once we have the data set is available, we start with the pre-processing technique. So in the pre-processing techniques, we do the color normalizations. Sometime from the whole slide images, we extract the patches, and then we utilize the patches for the identifications. And later on, we go for the segmentation steps. The segmentation is not mandatory; it is the optional steps. And it depends on the type of applications. Sometimes segmentations are included within the classifications, or sometimes we can go directly for the classifications, removing the segmentations also. So, and for the classifications, many times we exclude the steps. And then we go for the third step, that is known as the feature extractions. That is the most important steps in this AI techniques. In these steps, either we can go for the machine learning algorithm, which are many times used, which use the manual feature extractions, or we can go for the deep learning algorithm, which act as just a black box and it extracts the features automatically. Or we can add the additional features along with the deep learning networks. And then the last step is the classifications. In the classifications, we have the two type of classifications, either binary classifications. When I say the binary, means either it classifies the tissue in a normal or the malignant, or we may have the multi-class classifications. In the multi-class classifications, we further classify the malignant tissues into the another 4 types. So let me start with the image processing, data pre-processing step, or the image pre-processing step. So pre-processing means we want to convert the original data which is acquired through the sensors such that the most significant features can be identified and can be analyzed further. One of the major challenge is the appearance variability, as I mentioned.
So, Professor, sorry to interrupt you. I asked some question in chat box. If you answer that means you can continue, means it will help for me also. Thank you.
Okay. It is okay. The few questions are there. In which data set you used professor and why? So when I talk about my few contributions, at that time I will say that which data has been used. Mostly I use the Breakfast data set. Dr. Senthil, one of the question is from the Dr. Senthil Kumar. So I use the Breakfast data set because it provides the 4-time zooming and the different patches are there. And again, it is the only data set which has the multi-class classifications. So we use that data set. The another question is that how accurate the predictions are there and how this AI is helping to the MBBS. Okay, so after the couple of the slides, I'm going to discuss that what are the accuracy levels are in the theoretical point of view and how accurately they have been used in the clinical purpose. So I will answer this question later on. That will be included in my few after the couple of the slides after when we talk about the classification methods. And the second question is from if it is possible to create the single cell data set with deep learning algorithm, only we can use the tissues. Uh, when I'm talking about the histopathological images, we are talking about the biopsy, and the biopsy is capturing the tissues. And therefore, instead of single cell data set, we have to capture the tissues. The first reason. The second reason is that for the histopathological cancer classifications, we need to analyze the structure, and when we need the structures, we require the little large area. So instead of the single cell, it is better to have the tissues, and from the tissues, we can able to identify the structures. Okay, so I hope that this is what I'm talking about. And definitely, I'm just talking about the images because when we are talking about that, we are taking the tissue images only, and then we are talking about it. In the cancer classifications, there are many other way of imaginations are there, like X-ray images are there, or the MRI images are there. But I'm concentrating as of now on the biopsy-based classification only. In one of my paper, we classify that which methodology or which imaging technology is better for the particular type of applications. But I hope that as of now, based on the discussions, I'm confining my area for the histopathological images as of now. So I'm not going to talk about the other imaging technologies like MRI or the X-ray or other imaging technologies. Yeah. Okay. Okay, I will look at the chat. I'm sorry, I did not notice at the chat. Yeah. Okay, so I'm talking about the data pre-processing techniques. So as I mentioned that we want to enhance the feature from the tissues, and the data processing techniques include the 4 major steps. If you look here, one step is the color normalizations. The second approach is the filtering approach to highlight the image structures. The third is the denoising, to reduce the noise into the images. That is the Gaussian noise, or maybe because of the microscopic imaging technique, whatever the noise will be created. And lastly, we have to optimize the contrast between the object of the interest and the background. So these are the 4 major areas where the data processing will be applied. The challenges are that the appearance variability in the stain images is among the foremost challenges in the analysis of the histopathological images. And these variations are caused by the variability among the people, like clinical peoples or the laboratory peoples, which follows the various protocols among the laboratories, even in the fixations, specimen alignment in the block, or maybe the human skill in the preparation of the tissues, like maintenance of the microscopes itself, which create the color variations. So this may happen during the staining process. And this variation in the quality of the image will significantly affect the subsequent image classifications and the future extraction process. So we require the appropriate technique. If you look at the various studies, what are the specific techniques are used? So normal techniques are like they utilize the rotations to increase the data set. They apply the cropping techniques. Sometimes they apply the flipping methods. Sometimes they apply the noise explanation methods or the morphological filtering or the Gaussian smoothing they applied to increase the data set also, because if you have the small data set. And many times the morphological filtering will introduce to smoothen the low intensity foreground and the high intensity background while maintaining the structure informations. So I listed out the technique to the right hand side. The second step is the segmentation step. The segmentation, as we know that it is a field which identify, or we need to find the region of interest or the object. And in the segmentation process, it partitions the image into the non-overlapping regions, and it will separate the object from the background that are our interest or for the clustering point of view. And like we may use either clustering technique, we may use the edge-based detection technique, or we may go for the region-based techniques, sometimes thresholding or the region growing techniques. These are the previous technology which has been largely used for the segmentation purpose. Nowadays, deep learning techniques are also utilized for the segmentation purpose. So here I highlighted the few specific techniques which are used as a pre-processing for the classification point of view. Like clustering techniques are there in the KNN. The advantage of the KNN is that it requires the less amount of the data. But the problem with the KNN is that it may generate the incorrect clusters when very few pixels are present in the nuclei. The another approach is the active contour model, which accurately
Yes, hello all. Let us wait for a few more minutes. The speaker has some technical problem from his end. So let us wait for a few minutes. He'll join soon.
Good afternoon once again, sir. There was some technical issue, so we could not listen you. But I'm sure now the system is working from your end properly. Is it fine, sir?
yes,
Sir,
yes,
you
it
are
is fine
not.
now. Yes,
Yeah,
yes.
done, done. Thank you so much. Thank you,
Okay.
sir. Thank you.
Okay, so let me go back. Maybe I this is I discuss. Am I right? This was there in the slides. Am I right?
Yes, yes. This was the last one. Yes, sir.
Okay. So then I am talking about the future extraction method. So as I mentioned that future extraction is the could be done at the tissue levels or the cellular level. I'm audible, am I right?
Yes, sir. You're
Yes,
absolutely.
yes, you are audible.
Okay. And the objective of the feature extraction is to distinguish the benign and the malignant type tissues. And if we talk about the common features which is utilized, is either at the intensity level, or it could be a fractal levels, or it could be at texture features, or the morphological features are utilized. The texture features have been used mostly in the most of the literatures, and they are widely used. And few of the techniques which extract the texture features are based on the Gabor filter, or the CLA transformation method, or maybe local binary pattern, or the wavelet transform, or maybe gray level co-occurrence matrix are utilized. And sometimes few literatures combine the 2 or 3 texture features to improve the classifications. So let me go to the now classification stage. So this is the last stage, which is used to find the images, like it is a benign type, normal type, or the malignant type. Yes, any question, please? Yes, the hand is raised. So any question, please? Mr. Viral Parmar?
I think you, sir, you can continue. It may
Okay.
be by mistake.
Okay, fine. Yeah. Okay, so let me come to the now final stage of the classifications, which is the core area in which I am working now. So as I mentioned, the classification could be either 2 types. It could be a binary classifications, or it could be a multi-class classifications. When I talk about the binary, that means we can see that one of these, the normal or the benign type classification and the malignant type image classifications are there. If I go for the multi-class classifications, then it can be further, we can further classify the malignant images into the 4 categories. Like 4 subclasses are shown here: the ductal carcinoma, lobular carcinoma, mucinous carcinoma, and the papillary carcinoma. So these are the 4 type of the classifications in the multi-class. And as I mentioned, only the one of the database, that is the Breakis dataset, is providing this type of classifications, and most other dataset has the binary classifications only. As a part of classifications, there are mostly either machine learning methods or the deep learning technique has been utilized. So I am concentrating much more on the deep learning algorithms. So later on, after the few couple of the slides, we will see that what are the recent deep learning algorithm has been proposed by the authors, and how they are efficient in the classifications are there.
The professor, small doubt, professor. Previous slide you shown histopathology image. So various dye is used in this particular image because of nucleus, cytoplasm, and all. So how to use this data for deep learning, because each and every cell is having different colors, and the tissues also having different cytoplasm having different dyes. How to differ this type of colors or dyes in AI techniques?
The idea is that after the staining of the images, the color will be assigned. Am I right? If I go back to the, suppose one of the images which I shown here, let me go back very quickly, and suppose here, right? So this is the just I show image here, but actually these are the structures are there. If you look here in these images, like this is the stain images are there. Here you can see that the one is the color is the purple color and the pinkish color. These are 2 things are there. Yes,
that
in
is
the
different
left-hand side
dyeing
image.
method. That is different dyeing. In carcinoma and all, staining method is differ. That staining is also differ.
No, this is like I show you the carcinoma images also here. It is there. Okay, I have not put the images here. Okay, but there is the structural regions are there in these images. This is the whole slide images are there. Again, if we divide, I just zoom it in the small part, am I right? But when we took the patches here, and within the patches, there are this like, suppose if I took at the particular regions, then there is a we can see that variation in the texture patterns, that how they are integrated or they are overlapped to the each others, and within that patches how they will be goes into the like out of the particular regions.
Another one doubt. If you choose the particular region itself, you can collect how much data?
Yes, correct.
Because the
So
tissue is a lot of information in that particular tissues. You are selecting in a small square area for that your purpose. But if you go
correct,
for another structure, another area means it will give also another information.
correct.
Yes.
Yes,
Then how
correct.
much data you collect from this histopathology
No, no, no,
small
no.
square meter?
See, see, this is the question about the like how we are choosing the like tissue cells
Yes.
from the biopsy process,
Yes. Yes.
right? Because suppose
Yes.
if I take the suppose in during the biopsy, if I'm taking the tissues from the wrong place, then it will be always normal tissues are there.
Oh.
Am I right? So
Yes. Yes.
during the
Normal.
yeah, so during the biopsy process, what they do that they identify during the so first they do the X-ray or the MRI images, and from the MRI images they identify the particular regions from where they need to take the cells or the
Yes.
tissues.
Correct. Your answer
Okay.
is correct.
Yes,
Yes.
and from that cells we go further for the classification. So the biopsy is the step is the very important that from which area or the from which regions of the organs or the from the body part you are taking the tissues. Once the
No.
tissues are taken, we have the two choices only. Either it could be normal or the binning type based on the type of the structures will be there. I hope that I
Another one.
answered your questions.
Answered, but I have again have doubt. In histopathology slide itself, you can get how much data. That is my point of my question. How
In
much
the
data you will collect from that particular histopathology slide image?
it see this is the part of magnification that how much we are doing. Like suppose from the whole slide images, normally one whole slide images are captured. Okay.
Okay, okay,
In the and now in the whole slide images there are two methods are there. Either we can process the whole slide image directly, that is the
okay,
first part, or
okay,
the second part is that we divide the whole image into the number of patches,
okay, okay.
right?
Oh,
When I
okay,
say the patches means we are taking the small size of the image from the whole slide images, okay,
okay, okay,
and then for the each patch we allocate the labeling also.
oh, oh, oh.
That is a part of data preparations.
For histopathology image, at least they are one is they make two slides. I think if I am correct, I did previously in my research. They
Okay,
do two research two slides for same tissues.
correct.
Then only they kept. Which one is used? That is also another one important question because they are verified two slides in one particular tissues.
Mhm. No, see, this is the part of data preparation. That's what I'm telling you, right? So actually, when they prepare the data sets, there are multiple way the like validations are there in the data process, in the data preparations.
Okay,
Like when the
Professor.
pathologist, it goes to the pathologist, they are doing the, as you mentioned, there are two ways they are taking the in the stainings are there, and then that it will be go to the two pathologists at least to verify that they are able to label it well.
And also they collected from normal tissues also.
Yes.
Normal tissues compared with this histopathology tissues. That is my biotechnology research. If
Hmm.
you also taken that normal tissues in your data collection or not?
Normal in, of course, the normal
Normal.
tissue we have to take
Uh,
because see, when we go for the classifications and when we apply the automated approach,
oh,
okay, so
okay,
definitely we require the two, at least two labeling. Suppose if we go for the binary classifications, the two labeling must be there. One is the normal and second is the malignant type.
okay, okay,
Otherwise,
okay,
data set will become the bias. Bias means the model will become the bias. And it is suppose if I have the more type of the normal tissues in the my data set, then the
okay.
model will become biased and it will give you the mostly the normal classifications only.
Thank you, Rosa. Thank you very much. I again and again interrupt. It's the any
Yeah,
problem
no
to you?
worry, it's okay. It's better.
Thank
It's
you.
better. Instead of
Thank
keeping
you.
the
Thank you.
like questions at the end of the like these presentations, it would be better you ask in between.
Thank you. Thank you, Rosa. Thank you very much.
Okay, so these are the classifications which I shown here. That is part of the breakage data set. Okay, and as I mentioned, this is the only data set which has the multi-class classifications for the malignant as well as the benign type of classifications are there. Okay, so now let me come to the what are the different type of the deep learning techniques are there apart from the machine learning. So we know that ANN is nowadays largely utilized, and the ANN can be further categorized into the CNN network, or it could be a generative adversarial network, GAN network, that is the leftmost. And the last one is the large language model, LLM. And we know that the CNN is largely used or the widely used for the classifications, or maybe for the lump detection, or we can say the object detections and the segmentations. So for the each type of the CNN, like for the GAN, how they can be used for the histopathological images, like for the data augmentations, we can use for the synthetic imaging, or we may use for the contrast imaging, that is for the data preparation point of view, the GN is widely used. The CNN can be utilized for the classifications or maybe detections or for the segmentations. And the large language models, we know that they are based on the text generations. And therefore, for the management point of view, like automated report generations or the information retrievals, they are largely utilized. Sometimes one of the statement I told in the very beginning of this presentation is that after the treatment, how the methodologies are there. So to review or to analyze that part also, the LLM techniques are largely utilized. So let me quickly go with the GAN network. So we know that the GAN are the specific framework which designed for the unsupervised learning, and it is primarily used for generating the new data samples. And the new generated data samples are resembles to the given training data sets. And that will help us to solve the problem of one of the question is that how many samples are required. Like suppose if you have the large number of the normal and the benign tissues, or the normal tissues are there, so we require to generate the other samples so that the model will not become the biased, and we require the balanced data set in another way. So for that, GN can be used. So GN has the, if I quickly introduce the GN, it has the two component. One is the generator and the discriminator. And these two components, generator and the discriminators, are trained simultaneously in the competitive process. The role of the generator is to create the new data sample from the random noise. It is utilizing the Gaussian distributions, and it will try to produce the data which is indistinguishable from the real data in the training sets. And the generator will learn to improve its output based on the feedback from the discriminators. So here, if you see in the lower diagram, the generator is producing the data, and the discriminator will try to verify the data is real or the fake. And then from the discriminator feedback, again the generator network is improvised such that the discriminator will fail to produce classify whether the data is real or fake. And that applications will be help us to generate the synthetic histopathological images, which is resemble the real tissue samples. And this augmentation will help us to increase the diversity of the training data. And ultimately, it will lead to improve the performance of the classifications by providing the more example from the learned data. Now, what are the challenges are that so where we can say the assessment. So one question is there, when can we start the assessment from the, okay, this is about the ATL. Okay, so this is about the GAN. And so this GAN can be utilized for the two purposes. One is for the data augmentations and to make the balanced data set. And the second purpose of the GAN is to enhance the image qualities. So as I mentioned, that histopathological images may suffer from the artifact or the noise or due to the variation in the staining techniques. And therefore, we can train the GAN network to improve the resolutions and to denoise the images from the low quality improves. And then it can be utilized to train the classifier model for the further classifications. The second is we have the large language model. So large language model, the idea is that it can see the images and it have the language also to describe the contents of the images. So we have, if we are given the LML, which are able to adapt at the, and they are able to handle at the variety of the general purpose natural language processing tasks like sentiment analysis, then entity recognitions and the text classifications. And the key advantage of the LMM lies in their ability to contextualize the images. That means to describe the images with corresponding natural languages description. And then we can use the transfer learning approach for the same purpose. So overall, LM has the 4 stages. That is to integrate the advanced natural language processing technique with the graph neural network. And then we can propose the novel approach for the analysis of the histopathological reports. Sometimes we use the attention score from the LMM to construct the interpretable and the context-aware graph representations. We can incorporate the feature extraction method to identify the critical variables in the predicting the cancer metastasis that can enhance the model's accuracy and the interoperability. And LML also can help like they can provide the robust approach which can provide the valuable insight into the underlying data, and that it can facilitate the decision making and the improving the patient outcomes. So let me just focus on the now classification method. So in the CNN classifications, we have the 4 possibilities are there, like hybrid network, where we can integrate the multiple CNN network for the classifications. Or we can go for the modified CNN network, where we can change the network of the CNN network and we can design specifically for the histopathology images. We can go for the feature fusion techniques with the deep learning, because we know that the deep learning is extracting the features automatically. So manual feature extraction can be added with the deep learning techniques. And finally, we can have the explainable AI technique, where we can develop the algorithm that how the CNNs are able to classify the images, providing the visual explanations like heat map, which indicates that which area of the images are contributing most to the classification decisions. We know that traditional CNN will not work well, so let me focus on the hybrid networks only, and let me just come to my first contributions, that is the feature integrated approaches are there, and one of the approaches known as a spectral spatial feature integrated CNN network, where the wavelet is utilized to extract the texture features and then we can integrate with the CNN network. But the approach is little different. The normal approach is that we extract the wavelet features, then we use the features extracted from the wavelet to the CNN networks, and then CNN will classify them either for the binary or the multi-class classifications. But here we integrated the wavelet within a CNN network such that it will reduce the computational complexity, and the wavelet itself can be act as one of the hidden layer of the CNN networks rather than the separate extraction of the features. So here I have shown that how the images depends on the structure and the pattern of the cells, and we utilize the wavelet transform. We know that the wavelet has the oscillating functions, which is used to represent the data at a various scale and the positions. And wavelet are able to capture the both frequency and the location information from the images. So when I say the frequency means the spectral features and the location means spatial features. So therefore the name is given spectral and the spatial features. And they are allowed to capture the information at the multi-scale resolutions also. And we know that we have the large number of the wavelet families are there, including the hard, Dobensys, simulate, bioorthogonal, and many more are there. So let me come to the structures now, that how the wavelets are fused within the CNN network or the deep CNN network for the classifications. So the one of the diagram, you can see in the diagram where the wavelet transform are used. So the histopathological images are applied to the 2-level decompositions. and then the images are scaled down from 512 to the suppose 256, again from 256 to the 128. Then we utilize the CNN layers, the convolutional layers with a different size. Mostly we utilize the 3x3 convolutional features. Then for the each layer, we have the different like number of filters defined by for the each layers are increasing in the power of 2, starting from the 64 in the first layer, then the 120 layer in the second layer, and so on. Then we added the batch normalization process, which is utilized at the every layer, that after the each and every layer in the convolutional CNN layer in the network, that help us to improve the convergence problem of the CNN. Additionally, to increase the speed of the training process, we utilize the rectified linear unit ReLU functions that will help us to normalize the data. And at last, we utilize the max pooling operations, which help us to reduce the feature vector size, the number of feature size, so that it would be the speed will be increased in the classifications. And the performance has been classified for the 2 data sets. As I mentioned, we need to like apply the models for the multiple data set, then we can validate the model better way. So one of the data set we utilize the BRCHIS data set, and the second data set which utilizes the breast cancer classification challenges from the 2015s. And here the few comparisons are shown here. There we can see that the traditional CNN models, which are capable to have the accuracy of the 77%, if we integrate the CNN and the SVM, then it will increase up to the 83% accuracy level. Then one of the author proposed the recurrent neural network, and they applied the augmentations in the data sets to increase the size of to increase the data sets, and they are able to reach up to the 90.59 accuracy level. As compared to that, if we apply this wavelet-based structure with a CNN network, then the accuracy is comparable to the RCNN networks. That is the advantage we receive. But if you look in terms of computational complexity, then the model complexity of the proposed this wavelet-based CNN network is very, very less in terms of millions only, where the RCNN requires the 10 million parameters as learnable parameters as compared to the wavelet-based CNN techniques. So it maintains the accuracy level at the reduced computational complexity. That is one of the advantage has been offered here. The second advantage is that the wavelet are integrated within the CNN networks. So there is no separate stage of the wavelet transform is required. So as the image passes, the wavelet has been calculated and the features are integrated with the CNN layers, and that can be utilized for the classification purpose. So these are the advantages has been offered. The additional contribution is that apart from the binary classification, it has been tested for the multi-class classifications with malignant classification into the 4 categories, and the accuracy has been reached to the 97.45%. So this is how the model has been tested and validated for the 2 data sets, and the accuracy has been improved for the given data set. The second pattern is the local binary pattern. So now instead of wavelet, let's see that what are the, because LBP is also gain attention in the texture classifications. And it is one of the most powerful descriptor which is used in the most image processing techniques for the texture classifications. So what is the LBP? Normally the LBP will read the ones 3x3 regions, and it compares the center pixel with the neighboring pixels, where we have to define the like circle radius. Maybe so if I take the suppose circle radius R1, R is equal to 1, that means it compares the center pixel with neighboring 1 pixel only. If I take the R is equal to 2, that means it compares the center pixel with remaining 2 after those 2 pixels deviations. So when I take the R is equal to 1, we have the 8 neighbors. So the neighboring pixels are compared with the center pixels, and the pixel value which are smaller than the center pixels will be assigned to the 1. The pixel values bigger to the center values will be assigned to the 0, or you can do the vice versa also. Like you can assign the pixel values which are smaller than the center pixels to the 0 and remaining to the 1. And later on, the binary values are assigned. If you see in the diagram, like to the power of 0, to the power of 1, in the diagram, the binary labels are assigned, weightage are assigned. And then the calculation of decimal values are obtained. And that will be stored in terms of matrix with the same width and the same height as the original images. And this process will be repeated for the each and every center pixels to get the LBP matrix. And later on, the histogram is obtained from the matrix, and that histogram can be used for the classifications. So if you look at the mathematically, so you can see that this capital S will show that the center pixel will be compared and the value of the difference will be highlighted, and then the weightage will be assigned using the to the power of n binary weightage. So now how this convolution filter will be integrated into the CNN. As I mentioned, we don't want to go for the additional step of the LBP, otherwise that will add the computational complexities. So what we did that the LBP encoding is reformulated using the convolutional filter. We define the LBP features using the 3x3 window, 3x3 size. And you can see in the diagram that the filters are defined using the 8 filters because we have the 8 neighbors. So what we did, we defined the simple convolution of the entire image with this 8 3x3 convolutional filters. And after the convolutions, it is followed by the binarizations. Binarization means we have to allocate that to the power of n. And that will achieve the same goal as expressed into the previous slides. So you can think that, let's say that this is my x is the pixel value of the original image. The B is the binary classifications. The B is the binary classifications of this 8 filters, and the sigma is utilized as a Heaviside functions. That is the binary, and then finally by changing the operator Vi in the power of 2, we can calculate the LBP. And this formulated LBP operator uses the 3 color map, so it is applicable to the all 3 channels of R, G, and B. And the fusion of these 3 maps will be used at every layer of the CNN. So let me go now to show the structures. That what is the advantage we have. So if we utilize the LBP as a layer in the CNN network, LBP layer. Now I'm talking as a LBP layer rather than the LBP calculations. So it offers the computational advantages. The advantages are that the number of learnable parameter in the LBC layer, local binary convolutional layer, with 1x1 convolutions, as because we use the 1x1 convolutions in the 8 filters, right, are significantly very less than those of the standard CNN layer for the same size of the CNN kernels and the number of input and the output channel. Here, if you look here, let's say that my L and K will represent the input and the output feature map of the CNN layer respectively. And the size of the convolutional layer is defined by the n by m. And let's say that the P is the intermediate channel. So the number of parameter which is reduced can be calculated by taking the ratio of the required parameters of the standard CNN, like number of the standard CNN parameter in the numerator, and the number of LBP formulated CNN which is expressed in the denominator. Now, if my future map is P is set, or if I set the P, that is the intermediate channel, which is equal to the intermediate LBP values, like P is set to the n by m, then the number of computational of the CNN will be reduced by the factor of 9. So please refer the total calculations in the given paper, that is the multi-channel local binary pattern guided CNN networks. So if I compare here that regular CNN architectures with 20 layers, which require the 10 million learnable parameters. So instead of that, suppose if I use the LBP directed CNN networks, the number of parameters now reduced to the 1.56 million parameters. So from 10 to the 1.56 million parameter reduction we achieve. So this is approximately about 6.72 factors reduction will be there. parameter reductions will be there. And the advantage is that the regular or the traditional CNN network only uses the convolutional features only, but here we can integrate the LBP, the texture features, with the traditional features or the convolutional features, and that will help us to improve the classifications also. So here we can see that the overall structure where in the top upper diagram, how the LBPs are integrated into the CNN network is shown into the diagram using the 8 filters of the LBP. And the lower diagram shows the conceptual architecture of the whole LBP CNN network, where the images are resized to the 512 by 512. Then the LBP convolutional filter is introduced. Then we have the rectified linear unit. Then we have the CNN networks. And these 3 layers are repeated for the number of the twines up to the 20 layers. And finally, we have the classification layers of the fully connected and the softmax layers. As I mentioned, again, it is applied to the 2 data sets. And if we look at for the multi-class classifications from the Breakis data sets, then for each magnification level, it is able to succeed the average accuracy of the 96%. And the F1 score is around 97%. So this is the advantage we can see here. So this is the second structure we talk about. The third structure, because our focus is about the spectral feature along with the spatial features. So we know that the residual CNN network, RCNN networks are able to extract the residual features, and that is equivalent to the spectral features only. So let me see here that another model which we utilize here is the extended deep learning model using the residual features, where the residual features, so what we did that we modified the network of RCNN network, and then we extracted the residual features, and that will be used for the classifications. So the idea is that in comparison to the traditional CNN network, which provides the global features and which ignores the local features, right? So either we require the texture features as a local features, so which is not able to perform well. So the alternate approach is used, that is known as a global feature extraction with local feature extractions, and without any encoding technique and without any dimensional reduction methods. So let's say the example of the residual features. Let's say that my X is represent the features which is obtained from the previous layer of the CNN network. The XL which give us the output features if I pass with the residual network or the RNN network, and then XL minus 1 is from the previous layer input, and we assign the weightage from the layer, and then we can say that my XL which is obtained by expressed by the equation of this, that R of XL WL minus 1 plus XL minus 1. And if I want to get the residual features from this layer, then we can say that my residual feature is obtained by subtracting the current layer features like XL and the XL minus 1. So you can say that my residual feature is obtained, R is equal to XL minus XL minus 1. So this is the alternate approach to extract the local features, and popular for that part. However, the interpretability of this feature is limited because of the skip connections do not interpret the meaning information. If you look at the skip connection in the RCNN layer, it just pass the information from the previous layer to the present layer only. So there is no meaningful informations are extracted in that skip connections. That is the disadvantage of the RCNN network. So here we adopted the network and we make the residual network, the residual layer as a learnable layer. So if you look at the diagram, in the images, that is the learnable RCNN is introduced with objective to extract the local features in addition to the global features. So what we did that initially we trained the DenseNet 161 architecture using the Breakis dataset, and later on the residual layers are employed or applied to the features of the DenseNet network to extract the local features. However, we modified the skip connections. If you look at the skip connection has the few layers or the few blocks are there. It is the first is the kernel size of the 1x1 convolutional is used. Then we have the dropout layer. Then we have the batch normalizations, and we have the sigmoid functions. Now the role of the kernel, the 1x1 kernel in the skip connection is to provide the new learning feature from the pre-trained feature at each pixel level, because it is a 1x1. So at each pixels, it extracts the features from the images, and it keeps the size of the image same. So there is no changes in the size will be take place. And later we applied the sigmoid functions, which emphasize the difference between the newly learned feature and the pre-trained features. So because of the sigmoid functions, it emphasizes the features. So thus, this kernel, the 1x1 kernel, will give us the local feature at each pixel level, and then we can concatenate these features with the global features. So in the lower, the second branch, we can see that the 3 filters are there: 64 and 1x1, 3x3, and the 1x56 level. So that will give us the global features, and the modified skip connections with a learnable part will give us the local features. And this plus sign will indicate the concatenation of the features. And by concatenating these two features will help us to improve, to add the additional feature of the local one. Now the problem is there is a problem of the overfitting, and to solve the overfitting problem, we introduce the dropout, and the batch normalizations are added within the skip connection also. So these batch normalizations are added to solve the problem of overfitting. If I look at this level, so here you can see that the comparisons are provided again with the breakage data set for the multi-class classifications along with 4 malignant categories. We observe that the average test accuracy for the malignant.
এই যে সরকার আমি 2017 থেকে যাচ্ছে এটা টিভি চ্যানেলে আমরা কি করে সুইচ করলেও আসছে না
Prasanna Roy, please mute.
Okay, so here if we see that the average test accuracy for the malignant factor is 97%, and for the binary classifications we got the average accuracy of the 95%. Apart from that, if you look at the balance score of the precision and the recall, that is known as the F1 score. So if we observe that the F1 score for the PC images is slightly lower than the other classes, and the precision score for the PC classes is around 82.86% at the 100 times magnifications. If you look at the other magnifications like 400, 200, or the 40, then the accuracy is good, or the F1 score is good. However, at the 100 magnifications, the PC specifically for the PC class, it is 82% only, which is less as compared to the other ones. So this is the one stage where we need to have the improvement, or the weakness of the model will be there. And then we have the comparison with other literatures also. So if we see here that the diagram, then we can see that the traditional network, and we compare with the ResNet network also. And if we compare here that the model will be able to reach from 95 to the 100% classifications, except the PC, that is, as I mentioned, the accuracy is 85% only. But as compared to the other models, for the other multi-class classifications, it demonstrated the good performance. So these are the 3 major modifications which we proposed for the integrated approaches or the hybrid approaches. Now for the comparison point of view, we have to look for the other models, that how this AI model can be validated with the lab practices. As one of the question that what is the accuracy level of the each models are there. So we can see that as a part of theoretical approach on the online data set, we are able to succeed up to the 95 to 99% accuracy levels. But if we go for the practical case, that in the laboratory point of view, the radiologist performance, then practically the maximum accuracy reached from 79 to the 85% only with AI techniques. However, sometimes this has been reduced by the 50% also. So this is one of the challenges if we go here for the AI purpose. And this validations has to be formulated by the, because of the few rules. This validation are not carried out in the all the CNN comparisons, like how fairness it will be, right? So there are some guidelines are there, and there are six essential principles are there, like fairness, universality, traceability, usability, robustness, and the explainability. This that we need to increase, and this the improvement in this parameter will help us to increase the clinical trust and the adoption of the AI technology in the medical imaging. What is the universality? Means the principle recommends that the definition, the application of technical, clinical, ethical, and the regulatory standards which is used during the AI development must be well maintained. If I go for the traceability, in the medical AI algorithm should be developed with mechanism for documenting and monitoring the development process, that how much improvements are there. And they must be paired with a method to the continuously or periodically monitor that functionality over the clinical environment. If I take the example like monitoring tools to identify any discrepancy or the drift form, which is expected behavior in terms of accuracy and interaction with the end users, those who utilize these techniques. And then we can use this plan for the maintenance of interventions nurturing the AI models. If I talk about the usability, the AI tool must be usable, acceptable, and deployable in the real world users. Like it can be utilized for the physicians, radiologists, and the other end users. The last one is the robustness, which refers to the maintaining the AI's performance and accuracy when it is applied under the highly variable conditions. This is more important. And in the real world, outside the control environment of the laboratory where the algorithm was built and initially tested. If I take the example like development and validation of the AI product, must include the use of multi-center and the multi-vendor dataset. Multi-vendor means the dataset which has been captured from the one microscope to the another microscope also, and from the different clinical environment for the staining purpose only. And lastly, explainability. So it must provide the meaningful and the explainable of the prediction, that how the model predicts that whether it's a benign or the malignant at the end users. And that will help us to like algorithm mechanism behind the AI decision making process. So what are the challenges are there? So if I go about the clinical challenges, so definitely there is a lack of standardized protocol. This variation can introduce the biases and it can hinder the model generalizability. Further studies will be needed which allow the assess of the consistency in the AI performance across the different clinical setting and to evaluate their role to personalize the traditional strategy. The another challenge is the limited availability of the curated data sets. Like most of the AI-based algorithm for the cancer detection described in the literature that employ the like patches or the images from the single time point of to make the predictions. However, if we go into the real-time clinical scenario, the radiologist consider the other sources of the radiological information also, like it is expected from the prior images. Or sometimes they capture the data from the patient medical record also. So if we develop the AI, the decision-making algorithm, it must consider this all relevant multi-source data. As of now, we consider the single source data of the tissues only. And that will help us to acquire the further effort to compile such a large amount of data and the informations. And it is the key to allow the software tools to make the more accurate predictions. Let me come to the CNN challenges and what are the few research approaches has been used in as compared to the conventional CNN model. So recently, Vision Transformer has gained the attentions where they treat the images as a sequence of non-overlapping patches and they feed these patches into the transformer model. And by treating the images as a sequence rather than the grid of the pixels, because earlier the grid of the pixels are used as a pixel level. This vision transformer can capture the long range dependencies and the global context that can be missed by the CNN algorithms. However, the issue is that they are relatively high computational cost, and that could limit their adoption in the resource constraint images settings. Furthermore, the vision transformer usually require the large amount of the label data to train them effectively. And the problematic factor, given that it is a relatively limited availability of the annotated medical images. The second, the YOLO series are largely utilized as nowadays, that provide the faster and the more efficient than the traditional CNN networks, with providing the high accuracy with latest iterations. And they provide the annotating the bounding box for the YOLO, which is the labor intensive task, and that will be challenges, especially in the complex images with the overlapping structure that require the skill labor or the skill manpower. And sometimes YOLO may struggle with the class imbalance problem, where the certain classes are underrepresented in the training data. The third is the large language model. As I mentioned, this is the new techniques are there, which is nowadays researchers are utilizing it. The LMLs are primarily trained on the textual data, and they may require the extensive large fine tuning to adapt the specific language to the histopathological reports and the descriptions. The effective integration of the textual insight with the visual data from the pathology images can be complex and may require the sophisticated architectures. The output of the LML can be difficult to interpret, and which may pose the challenges in understanding the diagnostic reasonings. So these are the few challenges with the recent algorithms. The another two approaches are the autoencoder and the attention-based approaches. The autoencoder is the type of AI network that is used for the unsupervised learning, and primarily that is used for the data compression, feature extraction, and the noise reductions. Here, the diagram shows that how the autoencoder can be used for the feature extractions, and then it can be used to train the classifiers. So the challenge is that we require to design the effective autoencoders in a high-dimensional histopathological images, and it requires the extensive tuning. The autoencoder can easily overfit to the training data. That is another challenge, specifically for the data set of the small and if the data set is small or we don't have the diverse enough. The attention mechanism purpose is to replace the greater importance to the given part or the part of the input for the further processing. Excuse me. And the first attention model was used to improve the performance on the machine translation task. And later on, it is used with the NLP. But nowadays, they are utilizing for the image processing also. So the idea is that the convolutional layer is used to generate the attention score. And then later on, the global average pooling method is utilized. And the attention scores, then later on, they are normalized using the softmax function to produce the probability distribution over the spatial dimension that result in attention map. However, it increases the training time, the instability of the model, and many times it introduces the bias and the errors in the model, and therefore limiting the generalization and adoption of these models over the multiple data set is very challenging. So these are the few challenges, and these are the references which I used for the various data set listing out. For the proposed model, it has been already listed out in that. So this is all overall about the implications of the AI technology in the proposed method. So now I'm stopping here. If you have any questions, then please raise your question now.
Participants are requested to raise your question if you have any. Meanwhile, sir, can I please ask you to stop sharing because I want to share e-memento for you.
Yeah, sure. Okay. Yes, done.
Yes, thank you, sir.
Yeah.
So thank you so much, Dr. Hiren Mewada, for giving inputs for implications for diagnosis of AI-based histopathology in image classification. We please accept our gratitude as a token of respect and appreciation for delivering such a nice talk. Thank you so much, sir.
Thank you very much.
And I request any participant, if you have any query, please ask to sir.
Okay, no
Very good,
questions.
knowledgeable session, madam.
Hello, Hiren, how are you?
Yes, I'm fine. So before ending, let me take the moment of the to thank you for inviting me to the in this workshop as an expert of. Definitely, it is a wonderful opportunity for me also because the interactions and the questions will help me to learn something new also. And I truly appreciate it. I truly appreciate for the chance to share my insight and to learn from the each of you. And thank you very much.
Thank you, sir.
So should we have one group photo?
Yes,
I
yes.
request all the participants to switch on the video.
Madam છે ને?
Okay, madam.
Thank you so much, all the participants. And now we are waiting for our next speaker, Anubha ma'am. I think, sir,
Okay. Yeah, can I leave now?
so you may join if you wish. You can continue.
You may continue, not an issue. If you have time.
Okay, no, I'm leaving now. I have to go for the university now.
Okay, okay. Thank you very much.
Thank you,
Okay,
sir.
thank you very much, Dr.
Thank you
Chirag.
so much.
Thank you very much, Chirag sir. Yeah, thank you very much to
Bye.
all.
Hello everyone.
Hello, madam. How are
Hello,
you?
madam.
How are you guys?
Hello, ma'am.
Hello. How are you? So, shall I share my screen?
Ma'am, just a minute.
Let's start the formality first of all from our end.
Yeah. So I welcome Dr. Anubha Gupta ji, and I would like to introduce herself. Anubha Gupta received her PhD from IIT Delhi, India in 2006 in electrical engineering. She did her second master's from the University of Maryland, College Park, USA from 2008 to 2010 in education. She worked as assistant director with the Ministry of INB Government of India from 1993 to 1999 and as faculty at NSUT Delhi from 2000 to 2008 and Triple IT Hyderabad from 2011 to 2013, India. Currently, she is working as a professor at Triple IT Delhi. Professor Gupta has authored and co authored more than 100 technical papers and has two US and two Indian patents. This is the wonderful achievement she has. She is a recipient of SERB Power Fellowship in 2021 and IETE Professor SVC Ayya Memorial Award 2022. Her recent work on explainable AI model for cardiac disorder detection won the 2023 Lab to Market Challenge of India AI, which was introduced by Government of India. Her research interests include applications of machine learning in cardiovascular disease diagnosis, cancer genomics, cancer imaging, biomedical signal, and image processing, including fMRI, MRI, EEG, and ECG signal processing. We heartily welcome you, ma'am, and we are really appreciating your presence here. Second time, but this is online platform. Once we made offline, um, I would also like to show your profile. Just a second. Okay. Let me share my screen with you. So the topic of the day for Anubha Madam is measuring presence in virtual reality using machine learning. We heartily welcome you, ma'am. Now the online platform is yours. You can please may continue.
Thank you so much, Dr. Vandana. So first of all, I would like to thank Sarojini University for giving me this opportunity. Thank you, Professor Chirag, and thank you everyone for arranging this session. As a researcher, we keep doing work, but we would also like to take it forward and disseminate this information to a larger audience. So such platforms give us also this opportunity to discuss our work with the larger audience. So I'm really very, very happy to be given this opportunity. So let me share my screen. So I hope everyone can see this. Okay.
Yes, it's visible, ma'am.
Okay, thank you so much. So I'll begin. So the title of my talk is Machine Learning Based Classification of Presence, Utilizing Psychophysiological Signals in Immersive Virtual Environments. So this is the team. The work has been done by Shubhadeep Saha, who is a PhD student registered at University of Queensland, Australia. Dr. Chelsea, she is myself and Dr. Arindam. We are the PhD supervisors for Shubhadeep. This work has been published recently in Scientific Reports, Nature Journal in 2024. So what is presence? And why is it important and why we are talking about measuring presence in virtual reality? So I believe that participants are comfortable understanding what is virtual reality, where you conduct an experiment and the subject is sort of, you put a headset on the head of the subject and he is viewing a scene through that headset. And now it's actually not he's visualizing some scene and he is supposed to feel the presence in that scene. This is called as virtual reality because he's really not there. Maybe it's a place that you have created in a simulated environment. So he is actually not present there, but he is feeling as if he is present there. So that's called as a virtual reality. So there are a lot of applications of virtual reality these days. For example, in healthcare, particularly when we are dealing with subjects who are suffering with maybe neurophysiological disorders, like maybe something where they are suffering with developmental disorders. So their social connect is less and you want to train them at that time. Virtual reality based experimentation really come handy. Likewise, neuromarketing is now a known phenomenon and again helps understanding. We also do a lot of, for example, in entertainment also, lots of gamings are there where the person feels as if he's playing that game in that virtual reality environment. So similarly for learning and training also, this is very helpful. So what do we call as presence when we talk about virtual reality? So we define presence as the feeling where a person feels where he or she belongs to and what this person is feeling in the present time. So for example, you can see this picture on the right hand side. So inside the bubble, it seems as if he is transported to that environment. Maybe he is feeling as if he is flying an aircraft. So this is a virtual reality environment, but actually he is wearing a headset, and through that headset, he is visualizing something where he's feeling as if he is doing that thing in that environment at that time. So when we talk about presence in virtual reality, we would like to discuss this concept or measure this concept because a higher presence implies that it would imply more experience, a better experience in the virtual environment. So we define 3 types of presence here. Personal presence, a measure to of the extent to which the person feels being a part of that virtual environment. Social presence, where it refers to extent to which other beings, living or synthetic, also exist in the virtual environment. So for example, as we will see in the future slides, that we created a virtual environment where there were butterflies in the environment. So, and now whether social presence is like whether the person who is doing this experiment or is being part of this experiment also feels these other objects, living or synthetic, were present in the virtual environment. That is called as a social presence. Then environmental presence refers to the extent to which the environment itself acknowledges and reacts to the person in the VE. For example, the person feels as if he is walking, so whether his footsteps are now audible in the environment, so this is the environmental presence. So because your presence is actually going to impact or influence the experience and engagement in the VR environment, that is why it's really important to know whether the person is feeling how much engagement the person or how much presence the person has in that VR environment. So when we design any VR setup, we say that there are various parameters that would influence virtual reality presence. So for example, visual quality. So if it is a high resolution realistic design, it may induce more presence for the subject because he would feel like as if it is a realistic scene in which he is present. Likewise, audio effects and other feedbacks. So if, for example, the experiment requires a person to walk, as I just narrated, and if he is not hearing those footsteps, his own walking footsteps, while conducting a VR environment, he would feel less presence. But if he is also able to hear his own footsteps, if he is walking only at the same place, then he will feel more presence. Likewise, audio and other feedback such as tactile, olfactory, haptic movements, for example, hand movements, if he is able to feel as if he is actually able to control some objects, hold some objects in the VR environment, that induce better presence. Now, we also talk about latency, which becomes a very important parameter because display lag and perceived scene instability are seen to be directly correlated. So display lag also results in cyber sickness. So for example, you're doing a particular experiment, but sometimes while doing the VR experiment, the person feels as if a kind of vomit type of a feeling also develops, which we call as a cyber sickness. So as the cyber sickness increases, the presence decreases, and this happens largely because of the lag with the display and the perceived scene. Then the embodiment is again a very important parameter. Embodiment embodied in the character influences the user to feel more presence in the environment, whether the person is able to feel as if he is, so let's say there is an avatar in the scene. So if the person feels as if he is embodied in that avatar and is really moving and is able to move that, then that embodiment also gives a feeling of better presence. So for example, for this study, we designed 3 scenarios. This is a scene of low presence, then medium presence, and high presence. So if you look at why we are calling it as a low presence scene, if you look at this, look at the roads on the 3 scenes, low, medium, and high. You can see here the road has more texture. Here it is actually better than this, and here it has a lesser texture. Look at the grass here. The grass has very less texture, whereas here the grass has more realistic texture, and here it would have even better texture. So the high presence environment has higher visual effects, better scenery, higher resolution things, lesser latency, more embodiment. So all the 4 scenarios and more higher audio and other feedback, that's what we'll say is the higher presence scenario that we have set up in the VR environment as well. So for this design, we actually use the software, which is Unreal Engine, to create the environment. The devices which were used were, one was this VR headset, which is HTC Vive Pro HMD. Then, because we were collecting EEG data as well as the electrodermal data, so we used LiveM 32 channel EEG setup with a cap which was connected to the head and the sensors are attached, and there was a wristwatch which was collecting the electrodermal activity data. So if you look at this scene here, the entire scene was created, and it's about for one trial it's around 2 minutes of a trial, where the person is as if he is in a moving vehicle and he is sitting inside that and is moving on this road. So there are some turns and there are some objects in between that he encounters. So this is the study design. If you look at this, the person has headgears in his hand. This is the VR setup. This is the cap which is connected to the head, and you can see the wristband also, which is also collecting the electrodermal activity data. So basically, 2 physiological signals are collected while doing the experiment. One is the EEG and another is this electrodermal activity data. While the person is only moving through these hand gears that is available in his hand to do the experiment. So now let's look at the environments that have been created. So as I said, we created 3 low presence environment. which had lesser texture. Medium presence had more texture, object structures, and environmental detailing were more, whereas in high presence, detailed structures included in every object and natural elements. Latency was highest in low presence and 0 in high presence scenario. In audio cue, there was a noise cancellation in low presence, but in addition to noise cancellation in medium present, there was a soundscape. That means the surrounding sounds which are present in the environment to create as if chirping of the birds, etc., to create it, to make a feeling of that it is a realistic scene. Now in high presence, other sound effects, for example, step sound of the person himself has also been included to give it a more realistic feeling. Embodiment and control, no embodiment and control is there in the low presence. Only body, but no control is there in the medium presence. Whereas control is there with the haptic feedback in this high presence scenario, where the participants could actually catch butterfly which are there in the scene. So let us look at this task design and the code. So there were around 28 subjects. 16 males and 12 females were present. So, as I said, we collected EEG data and EDA data. In addition, a questionnaire, 2 questionnaires basically, IPQ and SSQ were also conducted. So basically, the people were also asked whether how much presence they are feeling using these questionnaires. But generally, a person may not be able to even understand the questions, what is meant by the engagement and being present in the environment. So they may not be able to respond correctly. That may be one limitation. The second limitation may be that maybe the person is not engaged during that experimentation, but would still respond on the questionnaire a bit differently. Nevertheless, the questionnaire is always collected, and we would like to see the correlation of the responses that we receive here vis-a-vis what we see in the analysis of the EEG and EDA data. So the experiment was actually conducted in 3 rounds. So round 1, because we have 3 scenarios, low presence, high presence, and medium presence. So we started with the 1 minute of blank screen. The person, so for example, there could be different combinations, low, high, medium, low, high, and even low, medium, high, right? Low, medium, high, and then high, medium, low, but high, low, medium as well, medium, low, high, as well as medium, high, low. So there could be these different combinations. But if we start with the LHM, this scenario, low, high, and medium, the second one will choose as high, medium, and low, and the third one will choose as medium, low, high. So then if the first one is chosen, the rest 2 rounds we fixed in this manner that will go in the round robin kind of a scenario. So initially 1 minute blank screen is there, then low presence comes for 2 minutes, followed by the questionnaire, then high presence, then questionnaire, then medium presence, then questionnaire. Then there was a 5-minute break. The person could take out the VR headset and sit comfortably. In the round 2, we didn't ask them to fill up any questionnaire so that they could do in continuity. Again, 5-minute break. And again, this time again, we had questionnaire in the middle. So this way, the study was designed. Now, besides this, for every subject, a baseline data was also collected when he is not in the VR environment. So he's just sitting there without that VR headset so that you can relatively compare the performance with the baseline and see how how the results are with respect to the activation in the brain compared to the baseline. So now this is the task design and the timeline. So we start from here. So initially, so if you see here, B1, B2, B3, there were actually 8 butterflies in total. So first butterfly appeared after 20 seconds, second after 25 seconds of the start of the experiment, then 45 seconds, 50 seconds, then the first turn of the road came. Second turn of the road came here, and then rest 4 butterflies. So this is how the whole task was for a 2-minute duration. If you go above, this was a 2-minute duration for every presence environment. So in every presence it was like this, but as I narrated earlier, that the environment were created a bit differently in terms of texture, latency, audio cue, and embodiment and control to create the scenario of low presence, medium presence, and high presence. So now this is the EEG data processing. So the headset, these are the different sensors that were connected, and the ones with the green, this is the data that has been collected in this particular setting. So now we look at the EEG data processing. So the raw data was first we do power line filtering, which is done using the noise filter, was done at 50 Hertz, followed by a low pass filter at 40 Hertz and a high pass filter at 1 Hertz. So that means that we were capturing the data between 1 Hertz to 40 Hertz. Now next, because humans also blink the eyes, so blinking of eye leads to eye blink artifact in the EEG data. Similarly, if although the subjects were told not to move, but still they may move slightly, which leads to motion artifacts. So all those artifacts generally we remove using independent component analysis. Fast ICA is a good tool. You can actually choose the algorithm and then remove it. So these artifacts were removed using fast ICA tool. And then channel-wise data was normalized for zero mean unit variance so that now it can be processed. So the normalized data then was divided into 3 frequency bands: theta band 4 to 8 Hertz, alpha band 8 to 12 Hertz, and beta band 12 to 24 Hertz. So as I said that it was around 2 minutes of data for one trial, so which is about 120 seconds. So out of that, after cutting off the edge 10 seconds, which were no activity, it was roughly 100 seconds of data. And these were divided into different epochs of 5 seconds each. So basically, actually, they were later on divided into 29 epochs of 5 seconds each, with around 30% of overlap in the data as well. Now, processing and feature extraction was done. So the literature was actually kept in mind while pulling out these features. A lot of features were actually created. They were roughly around 171 features, but then feature filtering and like using genetic algorithm was also done. So besides the regular features that you collect in any EEG data in these different bands, so the special processing features that were collected were, for example, frontal theta to parietal alpha wave power here. Similarly, beta to theta plus alpha in these channels, theta to beta average power in these channels, individual powers in each channels, differential entropy, Higuchi fractal dimension, etc. All these features were collected from the data. So because there we can see that if I compute these 1, 2, 3, 4, 5. So for example, Fz theta by Pz alpha, this was one. F3 theta by P3 alpha was another. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we can see that around 18 features are here itself. Then 3 features are here itself, which are computed for all the 3 bands, around 9 features here, and so on. So this is how the data, and it was these features were collected for every epoch for one trial. So a lot of features were collected for every trial. Now the data EDA, the way EDA data, so this was the EEG data processing, and then we also had the EDA data. So the data was detrended, normalized, low pass filter to only 1 hertz, and then it is generally said to have 2 components. One is the phasic component and another is the tonic component. Tonic component is a slow variation that keeps on going, and the phasic component is that component which actually is triggered because of the stimulation that is happening in the environment. So after separating these 2 components, then mean, median and other features were collected for this EDA data as well. Now, once we have done that, now we wanted to see how good are the features and what is happening there. So, for example, looking at the IPQ questionnaire total score, we looked at whether from participants to participant, like in the cohort, whether there is a difference in the high to medium level present score, the scores that they gave on for the when they were present in the high present environment compared to medium, compared to lower. And we did see that there is a huge difference in the score on the IP questionnaire as well when it goes from high to low. And you can see that the level of significance is less than 10 to the power minus 4 or so, or 5. From high to medium also, it is actually less than 0.05, so which p-value is less than 0.05, which says that it is also a significant difference, and medium to low was also very low. Now, similarly, when we looked at the SC, so you remember that we had extracted from the EDA data tonic and phasic components. So when we look at the SCL and the SCR data, SCL mean actually differed from high, this is high presence, to medium to low, but we see more difference every time between high to low compared to in between. So similarly, SCR mean was also statistically significantly different across the 3 groups: SCR kurtosis, SCR power spectral density, and SCL entropy as well. So now we actually train number of machine learning classifiers, and we said that if we have collected these features and we know that which environment the person was, now are we able to classify, looking at the data, whether the person is in high present environment, low present, or medium present environment, BR environment. So you can see that we got the best performance with the multi-layer perceptron, which is a multi-layer neural network. We got the best performance compared to all other methods, and the accuracy was around 93%. So we use different machine learning models: MLP, XGBoost, KNN, random forest, logistic regression, SVM. Total number of EEG features were 161, EDA were 10, and which led to total 171. After we used genetic feature selection algorithm, they were reduced to around 78 or so. Validation was done because we had only 28 subjects, so it was, and out of 20, although we collected data of 28 subjects, later on they were left as only 22 subjects who completed study in all aspects, and the data was successfully collected. So the validation was done as leave one subject out because the number of subjects are only 22. So that means we are making 22 folds. And every time we are leaving one subject out, and then we train on these 21 subjects and test on the 22nd subject. So when we are showing these performance, this is mean accuracy plus minus standard deviation. This is like accuracy on when we collect the results of all 22 fold classification results. These are the accuracy when we have done the averaging over all. So, so now we looked at the, once we have done this entire study, we also looked at the post hoc analysis. So now we looked at the brain topography plots and in low, medium, high. So for example, theta relative power or theta differential entropy, alpha band differential entropy, or beta upon theta plus alpha power that I had just shown as the features. And we could see that there is a difference in the brain topography plots as well. If you see the low versus medium, you can see that here on the brain there is more activation in medium, least activation in high, and most activation in medium, and low is somewhere in the middle. So here also, for example, theta D also we see more activation here. So sometimes we see more activation, for example, in alpha HFT, we see more activation in high. Sometimes for some features, we see more activation in low, and for some, we see more activation in medium. So visually also, we could see that there is a difference in the features, and those were sort of consistent as they go with the literature. Once we built the classifiers, we also looked at the Shapley analysis and looked at, for example, this is the classifier high versus rest, medium versus rest, and low versus rest. And we wanted to see like what features. So high is on this side here, low is rest, the two classes, medium and low are on this side. So the red color indicates that the feature is actually assuming higher value. So for example, if we talk about FP channel theta par, so FP1 channel theta par, so it is saying that in the high presence we got higher values compared to the medium and low present environment in FP1 theta. Similarly, if I look at FC2 alpha, we find that in FC2 alpha, FC2 channel alpha band par, if we are looking at that, we are finding lesser activation in the high presence environment compared to the low and medium, because low and medium are red and high present side is blue. So the ranking of the features is also in this order from top to bottom. So it says that FP1 theta is making more impact in making a decision whether it is a high present environment vis-a-vis low and medium. So we do see that these feature ranking changes from environment to environment, high, medium, and low. And we can also see that in some cases, for example, here phasic entropy in high present comes in between, and likewise we have different set of features for the three environments. We also looked at, so because medium versus low, we could see a bit lesser difference in different experiments and different feature analysis. So then what we did was we also trained a binary classifier to look at medium versus low classification and see now whether there is a significant difference. So this time again, we could train a classifier and the results were again 90 plus in terms of accuracy. And we could successfully also see some results on the feature set as well. And this time our tonic and the like EDA tonic and the phasic mean were also becoming significant features when it was medium versus low scenario in helping it differentiate. So what are the key takeaways from this research? Outcomes, prefrontal and frontal regions were most dominating regions to classify presence, which was felt, which was also seen with the data analysis. Apart from relative powers, beta by theta plus alpha was significant ratio-based feature. FP1, theta and beta powers show inverse characteristic features in high and low level of presence. Phasic EDA entropy kurtoses had shown significant differences among different levels of presence. And without any cognitive demanding activities, our D differential entropy feature can actually predominantly distinguish presence level, because if you see, D features were actually at the top in these. So in at least medium versus low, we can see that D was significantly at the top in most of these. What were the limitations? How the presence changes within the environment. For example, there could be a VR environment, and within the environment, when the person is conducting the experiment, how the presence or immersion of the person is actually changing while he is conducting. We couldn't capture that, and that is perhaps something that researchers can see for the future and design a study. How individual parameters change the response differently. So we just made a setup, but only the sound, only some parameters if we change, how they would change the response. So that means there could be an ablation study even on design of VR environment. And then we had done, so for example, a hard level embedding per se, but how the whole experience of the person is changing with presence really would be a nuanced thing, and that needs to be studied here. So this is all about my talk. I am happy to take questions, if any. So I hope, okay, so let me go to the meet. Maybe I can stop presenting and then take questions. Yeah, hello. Oh, there were many questions. Good.
Participants can ask the question to Madam.
Hello.
Yeah.
Yeah.
Yeah,
Good
please.
evening. Yeah. Good evening, ma'am. It was a really nice session. Ma'am, I just want to ask that significant testing. So, which significant tests are carried out for the model significant or feature significant one?
So for the when I said that we looked at different features, so we did ANOVA testing. So repeated measure ANOVA was also done on the individual features. Then the features were also selected to see whether there is a difference across the, because there are three scenarios, right? Then even to see whether like which features to select, as I said, we also use genetic algorithm to select the features. And once we built the model, then we also did Shapley analysis, which is again post-hoc analysis and is also kind of a significant testing test only, where you're seeing like which features are actually playing a key role in doing that classification. So I hope that answers the question.
Yes, ma'am. Thank you.
So there is one question which is on the chat also, the question that is asked is, please provide model number of device used, EEG data. I get, so these details are present in the paper also, research paper also. And this is open access paper, so you can definitely download. It was 32 channel, but we used 20 channels out of that. And finally, 17 channel data was processed, largely frontal and parietal lobe electrodes were used, frontoparietal, frontal and parietal lobes, as you are seeing here also. Yes, they are medical grade, they are good quality. EEG was medical grade, yes. Any other question that anyone would like to ask? No, they are not. So they are wet electrodes. You paste them. So emotive, for example, emotive electrode system is like the dry one, but these are pasted on the head. But they were fixed through the cap so that they don't move, or there is no like dry electrode just goes off while you're doing the experiment. But they were wet electrodes, not the dry ones.
Hello, ma'am. My question is that the shape analysis can be used for the selection of the feature also?
Shapley analysis is actually post hoc analysis. So Shapley additive analysis works on the game theory concept. So once your model is trained, then you run this algorithm on your model and the data, in the sense that I would forward pass a sample, and if the model is saying that it is actually class 1 sample, then Shapley algorithm runs on top of that on the trained ML model, and then tells which features have been seen by the model where he's saying it belongs to this class. So that is why Shapley runs afterwards. You're not doing feature selection with this, but you're saying which features are playing a key role in doing classification. It can be done in two ways. One is that you can do as a local explainability, which is you're running this algorithm on single sample classification results. And another is that you also look at the global explainability, where at a cohort level you're seeing that high versus low, what features, how they are ranked. So what I showed in the PPT were actually the global explainability graphs, but you can also draw local explainability graphs. So its codes are available. You can actually download and use those codes easily and integrate it with your ML model. And I have been using Shapley analysis in almost all my medical related work, and generally it works very nice. Although this is not the only algorithm. There are, for example, Lime. Then we have other visual saliency methods as well. But I have found that Shapley works very nice for at least medical imaging data for all sorts of data. Okay, so now another question is, what challenges
Thank you, ma'am.
Welcome. So what challenges are faced during collection of data? How to ensure collected data is suitable? How many hours of data collected? So I showed you the experimental study. So it was 2 minutes for one scenario, and we did 10 sessions each. So multiple times these subjects were actually asked to give the data. And generally, so Shubhadeep conducted this experiment in his lab in UQ. So I believe that, and as we said that initially they recruited 28 subjects, and finally 22 subjects data was usable. So the challenges that happen is that, first of all, if you're doing multi-session recordings, then the person should come for all those recordings. So that's one. And second, like the person should also do the experiment by engaging himself or herself into the experiment. So that you can figure out by talking to people, or maybe if it's your friend circle, then you know that means somehow you make it work, that the data collected should be really usable data. So you need to take care of those facts. Now another question is, how much online data is reliable? You mean that if we are scraping the data through online resources. So the data which are deposited or collected by so generally, if I have to figure out whether this data is reliable or not, I'll see that who are the researchers who have put up this data. What is the quality of the data? Have they given the complete experimental protocol along with the data so that we can understand that? And whether you are getting, because for example, here also IP, the questionnaires, 2 questionnaires were also collected. So these questionnaires also help you figure out whether the data is reliable or not. For example, we could do classification. So basically, using the EEG data, now we are doing classification. So that means that the data, and if it is giving more than any random result, for example, 93% accuracy. So that means the person also did the experiment with the dedication and we could also infer the same thing with which the experiment was designed. So I would say that these are nuanced things. Like per se we cannot say, but you need to learn to trust, or you need to figure out whether the data is reliable or not. Yes, Ruchi? Ruchi, you have raised your hand. Do you have a question? Else I'll take the questions in the chat. Okay, so the next question in the chat I'm seeing is, for such lab experiments, do we need to get any ethical approval or not? Definitely, one needs to get an ethical approval. So for this experiment study design, ethical approval was taken at UQ from their IRB board, and only after that the data was collected. Then Dr. Senthil is asking, is there any libraries available for our country? Is there any IITs develop whole India data collection? I'm not sure, because these study designs are different. So I don't know what do you mean by libraries. These are all open source tools you can use. So generally, and everything was processed through Python libraries. Now, if you're saying that library of data, I'm not sure. Generally, we go to Physionet or we look at Mendeley or other sources where people deposit data. Whether there is any effort, I know a lot of people collect EEG data from different experiments, but whether there is a effort to collate that data, I'm not aware of that. There might be some efforts now, given the fact that government is also pushing that India should have its own repository. If online data gives 100%, 100% accuracy is generally dicey. I would say not all subjects are really going to be fully engaged and going to do, or like for every minute they're going to be engaged. So if your results are 100%, there may be a problem the way you're using machine learning. It may not be a problem with the data. So for example, we always say that all medical data, EEG, ECG, EMG or anything, they carry human fingerprints. So that means when you're building machine learning algorithms, your train val test splits should be at the subject level, not at the like epoch level. So here also we made so many epochs, but generally what if a person who is not careful about the domain and would just apply ML may say that I'll collect all the trials of high, medium, and low, collect all of them irrespective of the subjects, divide them into train val test and start doing the algorithm. This is totally wrong, and you will get 100% results for sure. So that's why the way ML is applied, it's not that data would be always wrong, but the way ML is to be applied needs to be seen in the context of the domain. Any more questions? So I'm happy so many questions were there.
I request all the participants to switch on the video. And before that, I would like to give my heartily gratitude to Anubha Madam for presenting this wonderful session and giving a lot of information related to design study and machine learning AI algorithms, and how EEG works and what could be the deliverables after the research. As a token of respect, Madam, we would like to present you here the e-memento. Is it visible, ma'am?
Coming. Yes, thank you so much.
Thank you so much, madam. Thank you so much. It was really very nice your talk on measuring presence in virtual reality using machine learning. And we will be definitely in contact with you for any queries and the further assistance.
Yes. And thank you for giving me this opportunity. So I guess one more question was asked from me, which was the test. What about test? Where should we attempt? Will you send any link? Oh, so participant is
Ma'am, it is related to, the final test of this Atal FDP.
okay. So this
So I request everyone to please switch on the video for the last picture.
Hello, Dr. Neeta.
Hi, just I'm waiting for the end of the session so we can discuss.
Oh,
Yeah.
so everyone is here now. I can see so many people. Hi, Neeta.
Participants, is the last chance. Please switch on your video.
So I hope everyone enjoyed the session.
So we always enjoyed hearing from you.
Thank you so much.
One more picture, please. One more picture. Thank you so much, madam. Thank you for your precious presence over here. And definitely, we will look forward to seeing you again at SCAT. Now, I have already.
Today is really wonderful.
Thank you. Thank you. We have already posted the link for the second session attendance, and sooner we will be having the quiz link also. I request Vivaksha madam to take over this online stage.
Thank you. Bye-bye.
Bye, madam. Thank you so much for wonderful session.
Bye, ma'am. Thank you. Have a great, productive sessions forward. Bye-bye.
Yeah.
Bye.
Bye.
So, meanwhile, we are suggesting to have feedback from participants, and we want to know that what is your experience related to this 6 days FDP, and what you learned from the FDP, and what are the things that we have to improve in the upcoming FDPs.
Participants, please share your feedback with your willingness.
So this feedback is very important compared to that feedback given on that portal.
Yes, anyone can unmute themselves and share oral feedback.
Hello.
Yes.
Yes, sir. I am Dr. Shanti Verma from Lokoman Institute, affiliated with GTU.
Okay.
And I found this 6 days FDP is very informative, very wonderful, and I want to thank all the organizers of this FDP, because the speakers in this FDP are share very informative information in very detailed way. And my some PhD students are working in the same domain, and I am very thankful that I get very good information that I can share with the other audiences and other students also. with the help of this FDP. Thank you.
Thank you, madam. Thank you so much. Any other participants? Yes, Dr. Dhruti Sharma.
Yes, madam. Hello.
Hello.
Uh,
Yes.
yes. It was really very nice FDP. All the sessions are very good and very informative. Thank you so much for organizing such a wonderful FDP, Chirag sir and Vivaksha ma'am. Thank you. Thank you so
Thank
much.
you. Thank you so much, madam. Yes, anybody else wants to share their feedback? You can unmute
Hello,
yourself.
ma'am.
Yes, please.
Yes, it is very good session, very informative topics are there, and we learn too much inside this session. So again, we want to attend this type of sessions.
Yeah,
Very good
surely we'll
management,
inform you.
technical management is also very good. Left one day or one day,
Yeah.
otherwise all things are better. Okay, thank you.
Yeah, we are extremely sorry for that, but I hope rest all is fine. Anybody else wants to share something? Yes.
Hi, this is Chandra. I'm from industry.
Okay.
Also teach. So what I have been attending these sessions, though it is not mandatory. I'm attending to learn actually. So
Okay, that's great.
these sessions are well planned, and the topics are chosen carefully, and even the speakers also very experienced. And I think I have attended close to 6 sessions, 6 FDPs last few months, at least 6 months. I can say this is one of the best FDP what I observed actually, like in terms of topics and level of experience of the speakers and overall organization. Thank you.
Thank you so much, sir.
Hello.
Yes.
The 6 day session will be very informative, and then way of your organizing, and then what your struggle, it will be there. All the thing it will be overcome with the good approaches, and it will be there. Thank you, madam, for this workshop. I'm Professor Rajkumar from Jain Institute of Engineering, Chennai, madam. Thank you.
Thank you so much, sir. Yes, anybody else wants to share?
Hello.
Yes.
Yes, good afternoon, ma'am. Chirag sir and Nishika ma'am. It was really a very nice experience to be part of the FDP program. I have learned a lot too, and I am forever grateful to the organization. And thanks for Chirag sir and ma'am. Thank you so much.
Thank you so much.
We will share a few more such type of the FDPs and the sessions that we are planning in the near future also, which will be obviously in the hybrid mode or the online mode. So that please be in the touch. And also we are always happy as an university and as a college to have a collaboration with your college or the university, so that we can have a good work, good research work, and the good program with your university and yourself. So always you are welcome, and we will have some collaborative events in future also. So then after, we will not work as a participant and a coordinator, we will work as a coordinators only.
Yes, so one request to you all that whenever we share the quiz, do attempt the quiz and feel the feedback from your Atal portal. It is already there. So from your candidate participants portal, you can feel the feedback. Once you feel the feedback and you appear for the quiz, your certificate will be generated within few days. So do not miss to feel the feedback on portal. Anybody wants to share something? Okay, so
just a minute.
Yeah.
Madam, Ketki madam wants to share about our upcoming event Sampark.
Yeah.
So I shared the link of that event.
Okay.
Ketki madam, please.
Good afternoon, one and all. Myself, Dr. Ketki Pathak, and I have been associated with Sarvajanik College of Engineering and Technology, EC department, and myself also the branch counselor of IEEE SCAT SB. So this time we are organizing a Gujarat section flagship event, that is Sampark 2025, and SCAT College itself is a host institute for the same. So as all the fraternity coming all over the India, I would like to invite you, all your students as well as professional members or faculty members, for this Sampark event. As Chirag sir has already mentioned the link for the Sampark, you just visit the Sampark, in which we are having one datathon competition, in which students can explore their coding ability either in software design or hardware design, and they participate in our Sampark event for demonstrating their innovative idea. So we would like to invite them, as well as it is a networking event. So many opportunities they can explore if they will attend this Sampark event. So you can find out all the details. There are many other events are there. It would be on a 16th Feb, that is on Sunday. So if you are planning in group, we always invite you for our SCAT campus. Thank you very much, Chirag sir and Vivaksha madam, for giving me the opportunity and this platform to announce about Sampark event.
Yes, here some questions are there from participants. We will share a quiz link here only. It is yet to share. We'll share at 5, or within after 5-10 minutes we'll share it.
So meanwhile, you
And
can fill that feedback form
yeah.
on your portal itself.
Yes, Manojit Chakraborty. Feedback form will not be shared. It is there in your portal only. You have to log into your Atal portal, and in that left-hand side panel, there is a feedback option. So every participant has to fill their feedback from their own login only. So we are not going to share any feedback form.
So we are giving you time for the 10 minutes because it is mandatory. Without feedback and the test certificate will not be generated. So please give the feedback first of all, so that there is no formality left.
Yeah, and assessment link is not yet shared. We'll share it soon. Only feedback is to be filled from Atal portal. Attendance link we will share here in this chat box.
Good afternoon, sir.
Yes, good afternoon.
Madam, form where we can fill feedback form in Atal portal?
Yeah, Atal portal. From your login only you have to fill.
Okay, madam. And madam, quiz link?
A quiz link we will share within 5-10 minutes.
Oh, okay.
Hello.
Yes.
Yes, Chirag sir. I want to ask you one question regarding means how we can collaborate as a FDP partner with respect to the institute partners. Is there is any opportunity? And if there is any opportunity, then can I get your details for the further communication?
Yes, sure. There is an opportunity. See, if we are talking about, you are from, first of all, which institute?
I am from the Lokman Institute of Management and Computer Application, that is affiliated with the Gujarat Technological University.
Okay, and particular location?
Ahmedabad, Shivranjani.
Okay. So, if we are talking about Atal FDP, so Atal FDP has the main things that they are considering is diversity and inter-institute collaboration and same institute collaboration. So right now, suppose I am giving my example. Now that myself is from EC department, I am professor and head of EC department. Vivaksha madam is professor and head of IT department. So we have interdepartment collaboration as well as diversity also. So we can have such type of diversity between inter-institute also. So that's where we can apply, any one of us can apply together on the Atal portal. Okay, that is about the AICT Atal FDP. Other than AICT Atal FDP, there are so many ways that we can have the collaboration. So if you have any ideas in your mind and if you want to do collaboration with us, then you just share the idea and we can have number of funding agencies through which we can do the collaboration. As we have mentioned that this program is also sponsored by IEEE. So IEEE is also one of the funding agency. Which cost is one of the funding agency. Then after we can go for the DST also. So there are so many ways by which we can have the collaboration among us. And now the group is open for all of us. It will be not the admin only. So in future also we will post any event over there so that all of us can take the advantage. Suppose I want to come to some Chennai based college for some of the program, so I must know कि कौन सी college में क्या हो रहा है. So that I came to know just right now that one participant is from the Chennai. So that is good thing that we have good participation from all over the world, India.
Yes, yes. Sir, can I get your means contact details so we can talk further related to
Yeah,
collaboration?
my email ID is already with you, and I'm sharing my mobile number right now on the chat box itself.
Thank you, sir. Thank you very much. Yeah.
Okay, thank you. And those who are in Gujarat, specifically, we are inviting you on the 16th that you come and visit us for the Sampark event, and you can see the legacy that we are following right now. You can see our Luskin campus and how we are working. That also you can visualize, and we can enjoy a lot about the collaboration.
Attendance link will be disabled after 10 minutes. Okay, so all are requested to fill the form and it will not be pasted again.
Kindly fill your attendance as well as feedback on Atal portal.
Madam.
Yes.
What's later in a feedback form?
Sorry, you are not audible.
Attendance form
Sorry.
already submitted. Madam, attendance form already filled, but can I fill feedback form after 1 hour?
Yes, you can fill feedback from after 1 hour, but quiz you have to attempt from, today only from 5 p.m.
Okay, 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 madam.
Good evening, ma'am. Ma'am wanted to ask that the Atal portal is already showing the quiz. So can we start with it or the quiz
No,
which
no,
you
no,
will...
no, no. We will share the link for the quiz. You have to fill only feedback from the Atal portal. We'll share link here only.
Okay, okay. There also it is showing a quiz link, ma'am, to start
No,
the quiz.
no, but you don't have to attempt there.
Okay, okay, okay. Thank you.
Hello, ma'am. I'm filling the feedback form. I have filled all the but the submit button is not active till now.
For feedback, ma'am, you are talking?
Talking about feedback form, which I have fill all the fields whatever have given, but I'm not facing active submit button. My submit button is not get active.
You can refresh your Atal portal and again try to submit it.
Okay, ma'am. Okay.
Uh, Hello, everyone. Very good evening to all of you. On behalf of the organizing committee, I would like to extend a heartfelt vote of thanks to all those who have contributed to making this Atal FDP on AI-driven wearables and robotics, transforming the future of healthcare and telemedicine a resounding success. First and foremost, a special thanks to our esteemed sponsors AICTE, IEEE SPS, Sarvajanik University, and Sarvajanik College of Engineering and Technology. Without their support, this event would not have been possible. Their commitment to promoting cutting edge research and development in technology and education has been instrumental in shaping the future of healthcare and telemedicine. I would also like to express our deepest gratitude to our distinguished speakers whose expertise has enriched us throughout this program. Thank you to Dr. Amit Joshi, Dr. Shankar Parmar, Dr. Siva Teja, Dr. Utpal Pandya, Mr. Rahul Makhania, Dr. Monica Agarwal, Ivan Tashev, Maria Doneva, Dr. Rohit Thanki, Mr. Akbar Doctor, Dr. Hiren Mewada, and Dr. Anubha Gupta. Your invaluable insights into the field of AI driven wearables and robotics have inspired and motivated all of us to think critically about the future of healthcare and telemedicine. A huge thanks also goes to our hardworking organizing committee members, Ms. Khushbu Nayak, Dr. Ketki Pathak, Dr. Vandana Joshi, Dr. Ankit Kharwar, Professor Chaya Suratwala, Professor Karishma Desai, and Professor Ankit Patel. Your dedication, commitment, and attention to details have made this event a seamless and enriching experience for all the participants. We truly appreciate all your efforts. Last but certainly not the least, I would like to thank all the participants for their active involvement and engagement in this program. We hope that the knowledge shared during this FDP will empower you to explore new avenues in AI and robotics for the future of healthcare and telemedicine. Once again, thank you to everyone for making this event a success. We look forward to continuing our journey of learning and collaboration in this exciting field. Thank you and have a great evening ahead. Thank you all. So here now we are sharing a link of quiz, which is there in our chat box. So I request all of you to appear for the quiz. Yes, link is shared for the quiz. You can start appearing for the quiz. Yes, Dr. Rakhi Dua, feedback link will work after some time because it is Atal portal. You can keep on trying.